Welcome to the Non-Precipitating Types module for ForecastBuilder. My name is Patrick Guy, the Sioux in Duluth, Minnesota. A little bit of a longer module just because some of the tools take a little bit more to unpack. So here's the GUI. There's a lot of types: dust, fog, frost, haze, thunder, severe, smoke, sprinkles, flurries, freezing spray, blowing snow, a lot of types, right? You'll notice in the GUI that there's no freezing spray and blowing snow, and that's because when the temperatures for the entire time range are above 40, those two elements won't show up. There's a delete all option at the top. That's to get a clean slate. You don't have to run that every time if you're just updating certain elements or you want to populate certain elements. Again, you don't have to click delete all every time. So let's dive into this. First, pot severe. Pot severe is two things. It is the SPC categorical outlook married with 3-hourly SREF calibrated severe probabilities. GUI on the left has day 1 at the top, day 2, 3 at the bottom. So you first want to select your minimum risk category, which is basically your mask. So by default, it's slight. So that means slight, enhanced, moderate, and high outlook areas can have T+ added at the merge weather step. Again, this is then married to the 3-hourly SREF calibrated severe probabilities to trip pot severe. So where in that mask, that probability from the SREF is tripped, you get a value of 30 for pot severe, which then results in T+ at the merge weather step. So it's essentially a binary yes-no grid. So what happens is that the T+ mention will move spatially and temporally within the SPC outlook area as the threat changes through time and space based on the SREF probabilities. As you'll see in a lot of these GUIs, you can also change the edit area and time range that is being used to run this tool on. So here's pot severe on the left, weather grid on the right. Where pot severe is greater than 30, that's where you can get that greater than or equal to 30, I should say. That's where you get that T+ mention. And by default, it only just populates as 30. That's the trigger. Where you have 30 is where you can also add those severe attributes, large hail and damaging winds at the merge weather step. For sub-severe attributes, small hail, that can be added anytime there's thunder mention and where pot severe is less than 30. Pot thunder, there's two methods, but before we talk about them, we should say that you don't have to run them here if you're using the NBM as your precip type approach, because you can populate thunder at that earlier step. Okay, so there's, again, two methods. First, pot thunder from the NBM. And this uses the MOS-based calibrated total lightning probabilities from the NBM, and you can see what their composition is at the right. We have 1 hour probabilities for the first 36 hours, 3-hour probabilities from hours 36 to 84, and 6-hourly thereafter. No new GUI appears when you select this option, it just simply runs. Second is pot thunder from POP. And all that does is simply run the copy POP to pot thunder tool, the legacy tool. The default slider bar positions will simply match pot thunder to POP. If you want to adjust that slider bar to limit a thunderstorm mention, say you want rain showers to be more predominant, then we need to bring that max value for pot thunder to below your highest POP. Pot fog from dew point depression. First thing is we want to say, well, what do we want to cap our coverage at? Patchy areas or widespread? And then we're going to set our dew point depression and wind speed thresholds for patchy areas and widespread. Pretty standard 20, 40, 70, 20 for patchy, 40 for areas, 70 for widespread will be the pot fog values, again, associated with patchy areas and widespread. And that's kind of fairly standard values that you'll see for a lot of these elements. Pot fog from visibility calculates fog based on a combination both of the dew point depression and then your visibility. So it's essentially a marriage between your dew point depression and your visibility grids. So we want to set the dew point depression below which we want to let pot fog be greater than 0, and then the visibility controls patchy versus areas versus widespread. Again, it integrates very well with DAS because you're using the visibility grid. Blowing dust, this is the simple tool that only uses wind gust. You set your minimum gust for patchy areas or definite blowing dust. There is a more sophisticated tool that uses the NCEP air quality surface fine particulate matter concentration. This is pot blowing dust model. So this works great for gradient wind-induced blowing dust, but not so great for convectively induced blowing dust. Again, you want to set your minimum concentrations from that surface fine particulate matter concentration output from the NCEP air quality for patchy areas and definite blowing dust. Smoke and haze, very similar to the blowing dust except that it uses the near-surface smoke concentrations from the HRRR, and then we set our minimum concentrations for haze, for smoke, and we select our smoke coverage. Another haze tool, it basically just says where do we want to find where haze ends at. And this is defined using the visibility grid. Again, it marries well with DAS because you're using the visibility grid. Freezing spray. It uses the Overland 1990 equation. You can see all the inputs there are right. Again, the freezing point of seawater versus fresh water, depending on what office we're in and whether we are dealing with fresh or salt water. The values are unitless, so they are not in centimeters per hour or inches per hour. They're binned into none, light, moderate, or heavy freezing spray, 0, 1, 2, or 3. No new GUI pops up with this. It's all calculated in the background and binned in the background. Hot frost, it takes temperature, wind, dew point depression, and cloud cover, and then applies that to the logic produced by the University of Kentucky, shown at the right, to get you patchy areas or widespread frost. Sprinkles and flurries. A few things we have to do here. First is we want to enter the pop in which to begin this, so that's right here. We'll set our temperature thresholds for flurries versus sprinkles and a mix in between, and then what value you want to assign to pop, sprinkles, or flurries. So slight chance, chance, likely, definite. Basically our pop breakdowns. Now we come to what takes a little bit more explaining, and that is blowing snow. So before we really look at the details, we need to understand really the science behind all this and the factors that impact blowing snow. So once snow is lofted, it's really modulated by wind speed, obviously, and that lofting is dependent especially upon the characteristics of the snow and the air temperature. So in general, fresh snow and snow at colder temperatures, or just simply colder temperatures, requires less wind to produce similar conditions compared to older snow at warmer temperatures. And so one of the big drivers behind this is the Bagley blowing snow model from Environment Canada, which takes into account that wind speed, that air temperature, and the characteristic of the snow. Again, combining this, and what's powering all this is Bagley blowing snow model, research from NWS La Crosse, and the blizzard capital of NWS Grand Forks, North Dakota, and also by Takeuchi. So what we're looking at is if there is snow on the ground, impacts due to drifting snow start to quickly increase at 17 knots at colder temperatures. And then we drop that temperature down to 15 knots at warmer temperatures. Well, it may sound a little bit counterintuitive, but that's to help to account for those impacts from when we're near freezing and maybe the road temps are near to above freezing, and so it takes a little bit, we reduce the wind threshold because we get some of that snow that drifts on and melts and then it refreezes. So that's what we're trying to capture here. So as this wind gets stronger, snow particles are lofted, and then that's where the Bagley blowing snow model takes over. And again, this is a statistical model. It's based on a robust set of observations from the Canadian prairie provinces. It uses snow rate, temperature, wind speed, and snow age, so the characteristic of the snowpack, as inputs, and the output is the probability that visibility due to blowing snow will fall below a half mile. So there was a tech attachment in 2016, a CR tech attachment, and showed the output from the blowing snow model, and it correlated very favorably with impacts due to blowing snow. Because this method utilizes a really large set of observations and takes into account all those main factors for blowing snow, it tends to do better in highlighting characteristics of true blowing snow, so that impactful lower visibility. So at temperatures near freezing, this model requires significantly stronger winds to produce blowing snow than compared to colder temperatures. So it's important really to keep in mind that the output is the probability for visibility to be a half mile or less in blowing snow, given the deterministic inputs of wind, temperature, snow rate, and snow age. And so with all that in mind, the result is still a deterministic forecast of impacts of blowing snow. So what we can see here in this table is that these pot blowing snow values are color-coded to match impacts, minimum, low, moderate, high. They're associated weather grid outputs, patchy areas definite, and then definite with a quarter-mile tag for blizzard conditions, and then most likely headlines. So blowing snow, again, it's very sensitive to the strength of the wind, especially at those colder temperatures when we're falling below 10 degrees. So you can help to utilize that information to assist in your messaging for the event of where are we sitting in this kind of space of temperatures and wind and snow age and whether it's snowing or not. So when you run the tool, what's going to first pop up is a single initial snow depth grid, which can be edited by the user. This starts with the current north snow depth, looks back 8 days, and looks to see if a crust has happened. And that's if the hourly temperature is greater than or equal to 35. If so, it sets the snow depth to 0. But then snow is accumulated from that date onward in time using north snow depth changes. So that, say we crusted, but then we got new snow, okay, then we have more snow that can be lofted. So we can see in this table, if the snow depth is less than 1 inch, you can't get any blowing snow. That's just to really to account for where A, there's either not enough blowing or snow to be lofted, the snow is crusted, or there just isn't anything at all. The user can adjust that, again, for, say, where we melted off snow or where we know there is a crust, but maybe the logic hasn't captured it. Snow depth of between 1 and 2 inches is going to limit that blowing snow mentioned to areas at most. And then if the snow depth is greater than 2, there's no restriction. So after you click OK, the tool will calculate further snow depth at each hour into the future, and that's, again, using your forecast database to look at hourly temperatures and then hourly snowfall, which is breaking down your 6-hourly grid. So only the initial snow depth grid will be visible to the user. Everything else runs in the background as we integrate through time, and you do not need to create a new snow depth grid. In fact, just don't do that. Only just use the one that pops up. So what then is going to happen, the tool wants to know, is it there falling snow or not falling snow? And because there's different equations for that. Obviously, it's easier to get those lower visibilities when we have snow, falling snow, along with the blowing snow. So if the output is greater than 0 from the Bagley output, a pot blowing snow grid will be created. The output, again, is the probability for the visibility from blowing snow to be at 1/2 mile or less, and that's based on your deterministic temperature, wind speed, snow age, and snow rate. And this output is well correlated to impacts based on research done, again, at the blizzard capital of NWS, Grand Forks, North Dakota, and it's correlated to headlines. A pot blowing snow 1% indicates pure drifting snow, and that's based on one of the following items when our snow depth is greater than or equal to 2 inches. A, we have a wind speed greater than 17 knots, or if we're a little bit warmer, we drop that threshold down to 15 knots. That's to capture that snow that's going to drift onto the road. We're near freezing, so it has a higher potential to melt and then refreeze. There's an option that's configurable to make sheltered areas, which caps blowing snow at 49% or areas, and that's where we have for areas that have lots of trees. So that's it, folks. If you have any questions, nws.forecastbuilder@noaa.gov. Thank you.